Okay, hello everyone. I am Wang, and today we are going to present the topic that massive occurrence of benthic plastic debris at the abyssal seafloor beneath the Kuroshio Extension, the Northwest Pacific. I know the topic is hard, but we can easily translate it to a lot of plastic debris at the deep sea floor in Kuroshio Extension. So you can get a keyword is plastic and Kuroshio. So we already know there are lots of plastic in the sea, but we observe the plastic on the ocean surface is only 1% of the expect. Then the plastic, so we think the plastic may sink to seafloor because of the sand and the biofuel make plastic become heavier, like the animation. Yes, so half of the plastic in the ocean came from China and Southeast Asia, and most of them flow to East Southern Sea of Japan. So and this is called the Great Pacific Garbage Patch. So we assume the East Southern Sea of Japan might have lots of plastic in seafloor too. So the target in the paper is there the massive plastic at the deep sea floor and their density, distribution, and the composition of the plastic, and where the plastic move. So in the start, we need to expand some keyword that we can see there is a Kuroshio, and the Kuroshio went to there become the Kuroshio Extension. The current will become slower and things will stop at here and go around, round, and round, and round, and round, and round. This is called the K recirculation gyre. So we choose 3 sites to analyze this place and using 2 sites to be the control team. The site 8, 9, and 10 are in the KE or KERG. And the site 2 near the city is Sagami Bay near Tokyo. You can see. So we assume there are massive plastic at the seafloor. And the site 6.5 had a strong flow at the sea basin. So we assume there are less plastic at the seafloor. So the method we're using to analyze this place is using HOV to get a sample and using model to track how plastic move. The HOV is a Shinkai 6500 and using its robot hands to collect the sample. The temperature will be measured every second, and its camera can have the ISO equals to 4 million. It means we could take picture without any added light. The sample we get back will be divided to the 4 types: wood, plastic, metal, and others. And using H2O2 to clean the organism to make sure we can see the word on it. And only the debris bigger than 5 centimeters being collected. The density we use is using item per kilometer square. And using Fourier transform in spectroscopy with an attenuated total reflection divide plastic type. Actually, this is not the topic, okay? In the other side, we using model ESTOC to analyze the particle, how to move. The model is using for open sea, so the site 2, Sagami Bay, is not be used. Particle stop at the seafloor will be deleted and released again, so the number in the sea will be same. The table is 5 centimeter. The table is 5 meters and the mean of 5 years. So there is a result. We can see this at the site 6.5, the temperature is a little higher than other places because there are hydrothermal activities. It means volcano in the sea. Yeah. You can recall the place we found. Okay. The result that we see, you can see there are no debris inside 6.5. That's the interesting part. And we can see the most higher place at the site 8. And this is more than site 2. The site near the city. And the component they are, most of them are PE. So there are some interesting samples. In cyanide, we found the aluminum flowable balloon. And this is a historic database record that find the foil balloon in the sea. When we find it, the foil has been decomposed. But because some reason we lost it in the sea, so we did not collect the sample. And at the same time, we collect the plastic bag made in 1984. It means it has been made for 38 years. And the Satan also, we got a toothpaste, and it has been made around 14 to 15 years by its design to check. And the model tells us all the particle could move to seafloor in 7 days, and the particle at the seafloor will not move that much. So it means it will stuck at here. The speed you can see at here, and the side 8.9 particle all move eastern and stuck at 140 degrees east. And all these particles will start at 140 degrees east. So this is the result of the model. You can see we see the particle at a different place, but the results are similar. They all stuck at 140 degrees east. Okay, talk to the discussion. We have massive plastic at East Southern Sea of Japan, we already know, but whether the K and KRG system caused it. So we needed to compare to other places like world other places and Japan's other places. So in the world other places, we can see the K and KRG is more higher than the abyssal plane. The K and KRG is at the abyssal plane, okay? But it's not the world record at here. This is the world record. And result shows that's not the mean at the abyssal plane. And we compare to the Japan's other place. In Japan's northern sea, its density is only 335. And at the side 2, Sagami Bay, near the city, we see there are 2,730. And in the K and KRG is higher than all. It's 4,883, the density. Okay, and the sample we collected have few fission tools, so we assume the debris is from ground. And they stock. The model shows that the particles stock at 140 degrees E. So we see the map. We think it's by Izu Ozawa Ridge and Trench. It's here, the Izu Ozawa Ridge and Trench. So there's a more direction to we could analyze. But if the research is true in this paper, there are 6.5 billion debris in the K and KRG system, and there is 86,000 tons at there. So, jump to the conclusion. We found the massive plastic as K and KRG seafloor and their density, distribution, and composition, and where the plastic move. Let's just check our target. Let's just check like tradition. So this is the end of the present. Thanks, everyone.
The toothpaste, you said that it's around 14 or 15 years. Is there any generated date or something?
We could not see the generated age, so we assume it's made around 14 to 15 years if it's by the design. By asking their company when this design of toothpaste was made.
Yeah, because it's serious damage or dissolve in the sea, so I cannot judge the information from the picture. Yeah.
Yes,
Okay.
the paper, let's say, it just ask the company made it this toothpaste.
Since there is now studies that are trying to find the trash on the seafloor, do you know if there is some initiatives that are going to be made to try to clean the seafloor?
The paper did not mention how to clean this plastic or debris.
Okay, thank you.
So what does the K and KRG really mean?
K and KRG, it means the Kuroshio Extension and the K recirculation dryer. We already mentioned it, so we put it at the down. So you can see, hold on. Oh, I forgot to put it at this place. So this is a K and KRG system.
Okay.
I would like to ask about the HOV.
HOV, okay.
Yeah. So we know that the experiment has been going on for 5 years, right? 5 years? They have data for 5 years?
The data from 5 years is using for models, not HOV.
Oh, okay. So what about the HOV? They collect data for?
The HOV, they collect the data every dive.
Every dive? For
Yeah.
how long?
How long? Well, the paper did not mention it.
Okay, thank you.
That I wonder now that why they use the HOV sampling collected. They use this for what?
They're using for collect sample and take photo.
But you say that the model is the data of the model is from this.
Data of the model is it may used by the model is used by ESDOC, but actually I don't know what is ESDOC, so I can explain how they get the sample. And they didn't mention how to put this data into it.
Oh, okay.
Well, this is really nice. Huh? Okay, I learned something. Okay, so this story itself was easy and also interesting. So that was a nicely chosen presentation material. So I think all of you understand what's really going on, and also his starting strategy is also very nice. Like to simplify, it's actually providing the key main conclusion of the study. So this is also a very nice strategy. And I think at some point, and these are all, the introduction slides are also very nice. And at some point you talk about some Great Pacific garbage something. Can you print that? Did you print that somewhere on your slide?
The Great Pacific garbage.
Yeah, because you have time. I mean, in your presentation, yeah, you have time, so it would be great to print the keywords and maybe show image because you don't have 10 minutes yet.
Okay.
And then his presentation, his slide frequently reminded the audience the abbreviation, like here, sorry, not here, like here, for example. So when he was talking about the abbreviations, you can actually look at these to quickly remind you, okay, what this means. That was a very nice strategy. And regarding the presentation of results, okay. Actually, did you really mean? No, not yet. Sorry, can you go back to?
Which?
No, here, just here.
Okay.
Do you really mean module? Is that the word used in the paper? Module?
Model.
This reads module.
Do
you really mean module? Or do you mean model?
Model, sorry.
Okay, you were using, that was, you can check the dictionary. It has a totally different meaning. Okay? Okay. And the results, it would be because these your results, these are all very nicely presented. And the only suggestion I would have is because your results have many spatial information, like you talk about spatial 1, 2, 3, 8, etc. Although you have repeatedly show the map again and again, but you have to keep in mind that the audience, they simply forget the previous slide. You always have to keep that in mind. So the best strategy is to make this map really small and simply next
Well, that
somewhere.
would be too small.
You can actually, I don't know, is it from the paper or from you, this text,
Okay.
the text here? If this is from you, you can actually make the map smaller and then print again. Because even when you show them on different slides, it's simply impossible for me to check back and forth. Simply impossible. So it's always good to just put a smaller version of the map next to your data. You can actually, you will never overdo it. Trust me. You can always put map next to any of your data that has, why is it green here?
It's using for put my head. Okay.
Okay.
Because a lot of people they put word at here, and you can see the word.
Okay. So you can always put a map somewhere. That will really help the audience. Okay, and then and these are very interesting, and it's really nice that you provide some supporting information, keywords, so we know where to look at when you were describing the garbage. And these are very interesting. And then I want to remind you that speed, you need to provide unit.
Okay.
And then there was something, this is model results, right? This is model results.
Yes, this is model results.
Does this correspond to the result here? This has some relationship to this?
Yes.
Then I would appreciate that you, instead of putting them on separate slide, you can maybe use animation to show, okay, this, if you want to say station 6, 8, 9, 10, so maybe you can highlight them. I don't know actually where station 6, 9, 10, etc. It would be good if you can somehow combine the discussion with the model results,
okay,
instead of putting them on separate slides.
Well, this is not the discussion.
I mean results.
Okay,
results,
okay.
Yeah. All right. And again, here you are again talking about different places of Japan. It would be always good to add map.
Okay.
Okay. Like where's Northern Sea? What do you mean by Northern Sea?
Okay.
Okay. So then, because you have time, you don't have 10 minutes yet. So one way to make your information more informative is to give us better feeling what this means. That always means you need to tell us this weight corresponds to what? To something we are familiar with. Like how many adult body weight, for example.
Okay.
Right? Then we will have better feeling, that's really a lot. Or this not that a lot. That not that much. Okay, provide some comparison of the number.
Okay.
Okay. And regarding conclusion, this one is okay, but can you provide some more specific information here? More specific,
okay.
Like a density, provide some number. Okay, distribution, composition. You can actually use the map to draw the conclusion.
Okay.
Reuse the map. But overall, I think this one presentation is really nicely presented, and the topic is interesting. So I hope that next time you can make it even more interesting. Okay? Thank you.